Okay, so here is the second portion of concept one, dealing with the trig ratios, but specifically finding a missing angle. In order for us to do that, we need to use the inverse trig ratios or the arc. Well, in the calculator, it'll say arc anyways. Um, the inverse functions of sine, cosine, and tangent. So if you know the ratio of the trig functions of any angle, you can use the inverse functions to find the measure of an angle of a right triangle. So the inverse functions and they look like this in the calculator. They have a little -1 on the top of them. To find the measure of an angle of a right triangle. So what we would essentially do is take the ratio that the sine, cosine, or tangent function represents and put that in place of the theta that we would normally write. So let's take a look at some examples of that happening. So in our first example, it might be helpful for us to label the sides of the triangle so we can figure out which function we need to use. So in this case, if my theta is there, this is my opposite side. I know the side opposite of my right angle is my hypotenuse, and that must make this little side here our adjacent. So since I'm given the adjacent and hypotenuse sides of the triangle, I should use cosine. So normally I would say the cosine of my angle is equal to adjacent over hypotenuse. Then I would take my numbers that I'm already given and say I would be 7 over 23. Now, I don't know what my theta is, but what I can do is I can take my theta measure, my angle measure, and I can find it by finding the inverse sine of 7 over 23. So I'm essentially swapping the place of the ratio and the theta and using my inverse function. So if I were to put that in my calculator, make sure you're again in degrees. The arc cosine, or the inverse cosine of 7 divided by 23, is equal to approximately or roughly 72.3 degrees. That's how you would go about calculating that. Again, you put that in your calculator. You can use your cell phone calculator, but make sure it's in scientific mode in order to do that. Let's try again. If I have a situation like this, I know this is my opposite side, and this is my hypotenuse, so I know I'm going to use sine. So I know that sine theta sine of theta is equal to opposite over hypotenuse. So then sine theta is equal to 200 over 400. And you could reduce the fraction if you wanted to. You could reduce it to 1/2. But to find theta, we would use the inverse sine function, sine of -1, or the arc tangent, or the arc sine of that fraction of 200 over 400, or 1/2. When we do that, we should get 30 degrees. Yes, you should get 30 degrees exactly. So it's not an estimate, it's an exact. So that triangle is actually a 30, 60, 90 triangle. And actually, if you recall, in a 30, 60, 90 triangle, the short side is x, the hypotenuse is also 2x. So double the short side there. So That is something we learned in concept 36. Let's take a look at a few other examples. 3 and 4 are very, very similar, but I'll just solve them really quickly. You would find the tangent of x would be equal to 20 over 37, opposite over adjacent. So x is equal to the inverse tangent, or the arctangent, of 20 over 37, which approximately is 28.4, roughly. X is approximately 28.4 degrees. And for this one, this is for example 4, we have another sine function. This is opposite over hypotenuse. So the sine of x is equal to 15 over 24. We could reduce this if we wanted to 5 over 8. So x would be equal to the arcsine, or the inverse sine, of 5 over 8. 5 over 8, and that would be approximately 38.7 degrees. The cool thing about equations is equations often represent real-world problems, or they can. So in this problem, Jaden's flying a kite, and he lets off 275 feet of string, and if the kite is 150 feet above ground, and assuming the string is straight, what angle does the string make with the ground? So if I were to draw a little picture of Jaden is here, and he is standing there with his kite, and he lets off the kite into the air, and we know a few things. We know that Jaden has let 275 feet of string out, and the kite's up here. And we know that the kite vertically is 150 feet above the ground. What we want to know is, what angle does the string make with the ground? What's angle theta? Well, again, I have a opposite and a hypotenuse in relation to my angle. So this would be a sine function. So sine of theta is equal to 150 over 275. And you could reduce that by 20, they reduce by 25. They factor by 25, but we don't need to. Theta is equal to the inverse sine of this ratio. And we put this into our calculator. The inverse sine of 150 over 275 is around, theta is around 33.1 degrees. So it's cool. It's pretty cool. We get to solve a real-world problem by finding that angle that's being created. Now, this problem may look a little interesting because we have a combination of problems, a combination of triangles here. But I want to find DE. I don't know what DE is. I do know some information though. Say that I wanted to find this y here. Well, this y is the opposite side of angle C, which is 61 degrees. So if I said that, and 24 is the adjacent side, so if I have opposite and adjacent, I know I have tangent. So tangent of 61 degrees is equal to y over 24. Well, we learned previously that in order to solve this, I would take my multiply my 24 on both sides. And y is equal to 24 times the tangent of 61 degrees. So y here is approximately, let's put it to the calculator here, 24 tangent of 61 degrees. So this side, FD, that I've labeled as y, is roughly 43.3 units long. Now, we are almost done. We're not quite done because we want to find the value of x, or DE. Well, now that I know my angle DFE is 19 degrees, and I know my FD length is 43.3, I want to find my opposite side there. So again, I have a tangent situation. My tangent of 19 is equal to x over y. Well, since I know that my y is 43.3, I can substitute that from where my y is. So 43.3. The cool thing is we can solve it just like we did the previous one. We're going to multiply by 43.3 on both sides. So x is equal to 43.3 times the tangent of 19, which is approximately 43.3 times the tangent of 19 degrees. 14.9 units long. So that, my friends, is our final answer for DE.